Firewall solutions can come in the form of hardware appliances. So for example, it might run on a router, or it could be software running within a Windows or a Linux operating system. Now that includes network and port address translation solutions. Let's start by talking about port address translation, otherwise called PAT, P-A-T. So we know it can be hardware or software. However, what happens with this is that we've got multiple internal devices. Let's say, for example, that on a home network even, you've got a bunch of smartphones, smart TVs, laptops, and tablets. They all get out to the internet using a single public IP address. That would be the IP address configured on your port address translation gateway. Now, depending on your network, that might be your Wi-Fi router or some other device on your network. The idea is that we are allowing everyone to get out through a single IP, but we're also protecting the true internal identity of all of those internal clients. Now, if that sounds an awful lot like a forward proxy server, I don't blame you. It's similar, but it's not the same. And this is where you can get an exam question that might test your knowledge of the distinction between the two. Now, let's start for a second by thinking about a forward proxy. Internal clients, their IPs are hidden, just like they are here with port address translation. That's the same. But then we have to think about what happens with forward proxying. The client makes a request that is then sent to the proxy server, and it goes out and gets that request and potentially caches it. Okay, but with port address translation, there's no caching. Also, with port address translation, dare I say that this applies to layer 4 of the OSI model, whereas forward proxying applies to layer 7. What does that mean? What it means is that a proxy server can say, listen, before I'm letting you go out and fetch content on the internet, I'm going to force users to authenticate. You can't do that with port address translation. With port address translation, if you're on the network and you've got a valid IP config, out you go. That's not how forward proxying works. It can require authentication, so make sure you know the distinction for the Security Plus exam. Now let's take a look at a diagram of port address translation, because another way you might be tested on this is having some kind of a diagram like we have here, and then there are questions being asked about that diagram. So what do we have here? We have port address translation, and we have two internal clients shown on the left. And their IP addresses are shown, 192.168.1.10 and .11. So what happens then, to partake in using port address translation to get out to the internet, those clients would point to the PAT router's IP address on the LAN, so the local IP on their LAN, point to that as their default gateway. So there's no software agent that needs to be installed on those client devices. They're just pointing to the PAT router as their doorway out, so to speak. So when we have clients that do go through the PAT router out to the internet, what happens is the PAT router maintains a translation table in its memory. Now let's look at the PAT router table shown here in our diagram. So we've got private IP addresses that map to each of those two clients, and they're each assigned a unique port number. But then when they go to the internet, they are assuming the PAT router's public IP, which here is 200.1.1.1. That's the same for everyone on the inside going out. They all go out using that single public IP. Well then, how can it track unique sessions? The port numbers. That's why this is called port address translation. Be careful. There are a lot of network technicians out there that will incorrectly call this NAT, network address translation. Not that we're trying to split hairs, but technically that's not quite correct. So of course, we have to talk about what NAT is then. So network address translation, it's similar to a reverse proxy. Remember, a reverse proxy sits between internet clients and servers on the inside that should be connected to from the internet, but in a protected way. It hides the internal IP addresses of servers to allow connections to them. So a reverse proxy server is a layer 7 type of appliance. Okay, that means it has a lot of intelligence. It can look at URLs. It can require authentication. But NAT is OSI layer 4. But it does the same type of thing as a reverse proxy. It allows internal services like a web server you might be hosting. It allows that to be reachable from the internet You would map an IP address and a port number on the public side of the NAT router to an internal private IP address and port number to allow connections to an internal service. So the internal service IP addresses then, such as for our example website, are hidden. Let's take a look at this in a bit more detail in a diagram. So in the diagram for network address translation, on the left we have external internet clients. And the clients would connect to a public IP address and port that's been configured on the NAT router. If we take a look at the NAT device memory table, we see that the public IP address that it's listening on is 200.1.1.1, and it might be listening on port 443, and then it might have another public IP, 200.1.1.2. So two public IPs here, each listening on different port numbers, 443 for a secured website, 22 for SSH. That gets mapped, as we can see, to internal private IP addresses on those same port numbers. So if someone wants to connect to our Linux server through our NAT gateway, they would be connecting to 200.1.1.2 port 22. But that actually gets sent to 192.168.1.11 port 22, which is our protected internal SSH server. So remember that port address translation then allows multiple clients out to the internet through a single shared public IP, and network address translation is used to host and protect services that are visible to internet clients.